Hey everybody, I wanted to spend a little bit of time talking about space exploration, and specifically I wanted to talk about how we explore the solar system with telescopes. So there are a whole bunch of Earth-based telescopes, and the telescope, just so we know, is the instrument. That's the thing we look through. And the observatory is the building that houses the telescope. Okay. So, and there's a whole bunch of observatories all over the place. Even close to here, I think Rowan has an observatory and they have a planetarium. Okay. So there's a lot. I know that also I think the Franklin Institute in Philadelphia has an observatory. There's an observatory is up in Princeton, things like that. So there's observatories in a lot of different places. So I wanted to make sure that we're aware of that. Okay. The easiest thing for observatories to do, or for telescopes to do, is to gather light. Okay. Observatories can gather all sorts of electromagnetic radiation, but light is the most common one. So these are some of the more famous observatories. There's the Keck Observatory that's on top of the one of the Hawaiian volcanoes, and on Mauna Kea, and so the Keck Observatory is up there. And then Mount Palomar, San Diego, is one of the. For some reason, I always think that this is one of the more famous ones, even though it's in San Diego and near a large urban center. I still think that it's a pretty famous observatory. At one point, I think it had the world's largest lens in it. So that was pretty cool. And then the Vatican has an observatory, and this was made famous years ago. There was a book by Dan Brown called Angels and Demons, and so it was like a bit of a thriller mystery sort of book. And the Vatican Observatory is there. And then another one is Kitt Peak in Arizona. Those are some of the most. Kitt Peak is a very very popular light observatory. Just to give you another example, I went to school at a small liberal arts college out in Western New York, Alfred University, and we had a 5 observatory complex with 5 different telescopes when I took astronomy in college, and it was built by one of the professors there, and had different telescopes in each observatory, each building, and it was a lot of fun. So, like I said, it's common to have visible light observatories, and they are all over the place. Okay. One of the things I also wanted to do was to explain the difference between a radio telescope and a light telescope, and I'm going to do that by calling up my my notepad, and I will explain it. So a telescope, no matter what, whether it's a light telescope or a radio telescope, or even an X-ray or gamma ray or infrared telescope, UV telescope, okay, the whole point is that things give off radiation. And remember, light is a form of radiation. So a light telescope will collect light from a star, and then you can see through the telescope the light that's being given off. And you can say, hey, look, here's a star, and that star is giving off red light, and I can see that. Okay, well, certain objects in space not only give off light, but they also may give off radio signals. Okay, so I will symbolize radio signals as a little lines. Instead of collecting light signals, I can collect the radio signals. So I'm going to take this thing here, and I'm going to move it over here. And so I take light and what sorts of things collect radio signals. And so this radio signal will get collected on the dish, and then the person that's looking at the radio signal can interpret that. So we don't need to just collect light from space. We can collect radio signals from space. And actually, some of the radio signals in space give us way more interesting information than the light does. Okay. Another thing that can happen, and this is something that a former Collingswood student is working on, is we can collect microwave radiation. One of the things that happened in the past is stars gave off a whole boatload of microwave radiation. So if you have stars, what they can do is they can give off microwave radiation, and I'll symbolize microwave radiation with a black squiggly line. And so then you can collect the microwave radiation. Well, you're not going to use a telescope like you would to when you're doing visible light. You're not collecting that. This is somebody's eye, just to let you know. Okay, looking in there. Okay, you're not going to use a radio dish. Okay, you're going to use a microwave detector. And it turns out that a microwave detector looks very similar to a radio dish, but I'm going to color that red, and I'm not going to have the big thing in the middle. Okay, so a microwave detector looks kind of like a big radio dish. So we're collecting microwaves. And so that can give us a lot of information about the origins of our solar system and, well, actually our universe, because stars give off a lot of microwave radiation at the very beginning of their life cycle. We can look at stars by collecting any one of these radiations, okay, whether it's microwaves or light or radio waves. And that can give us a lot of good information. Okay, so Earth-based telescopes is a very powerful way to determine what's going out in our solar system and our universe beyond, but a lot of things in our solar system. Okay, everybody, have a great day.